Good day to each and everyone. How are you today? Are you now ready to learn? Welcome to our lesson in this module, which is circular permutation. In this topic, you are expected to find the number of arrangement of objects in circular permutation. And to go on with, let's answer first the pretest. Directions. Identify what is being asked in each question. Write the letter of the correct answer in your paper. Number 1. Which is true about circular permutation? A, B, C, or D? The correct answer is letter B. Number 2. How many ways can the 7 persons be seated in a circular table? Is it A, B, C, or D? The correct answer is letter C. Number 3. In how many ways can 4 couples be seated at a round table if the man and woman want to sit alternately? A, B, C, D. And the answer is letter A. For number 4, how many ways can 8 differently colored beads be threaded on a string? A, B, C, or D? And the answer is letter D. And for number 5, at a dinner party, 6 men and 6 women sit at a round table. In how many ways can they sit if Bobby and Rose sit together? Is it A, B, C, or D? And the correct answer is letter B. Thank you guys, and your effort in answering the pretest is highly appreciated. And now, for the recap. Direction. Create a problem that satisfies the given factorial notation about distinguishable permutation or permutation with repetition. Number 1. 8 factorial divided by 3 factorial times 2 factorial. Number 2. 9 factorial divided by 4 factorial times 2 factorial. Write your answer in your notebook and we will check it later. Now, let's proceed to the important part of this journey, which is the lesson proper. And before we proceed, let's answer first the situational problem. In how many ways can 3 people, A, B, and C, be seated around a circular table? If we have 3 persons, and if we want to arrange them in a line, then the total number of permutations of 3 persons taken all at a time is permutation of 3 taken 3 is equal to 3 factorial, which is equal to 6. We have the following linear seating arrangements as ABC, ACB, BAC, BCA, CAB, and CBA. But in circular arrangement number 1, in that arrangement, if you move clockwise direction, you can see that B is always at the left of A and C is always located at the right of A. While in circular arrangement number 2, you can observe that C is always at the left of A and B is always at the right of A. Now, the circular part, if we arrange 3 persons around the circular table, as shown in the diagram, notice that the arrangement does not change even if each person move his position by 1 place. In this particular arrangement, C is always on the right side of A, and B is always on the left side of A. Hence, it represents one permutation. There is no starting point in the arrangement of things in circular pattern. So, when each person moves his position by one place clockwise or counterclockwise, the positions are not changed. Hence, in general, if we have n elements, then the total linear permutation of n elements taken at a time is n factorial. And we observe that n linear permutations correspond to one circular permutation. So, for n elements, circular permutation is equal to n factorial divided by n is equal to the quantity of n minus 1 factorial. Now, if we solve the above problem, we get the total number of circular permutation of 3 persons taken all at a time is 3 minus 1 factorial. There are 2 possible arrangements as shown in the above diagram. If you consider the direction, the clockwise and the counterclockwise order, then the scenario changes, like a bracelet, keyring, and the like. So, if the clockwise and the counterclockwise orders are not distinguishable, then the total number of circular permutation of n elements taken altogether is the quantity of n minus 1 factorial divided by 2. But if bracelets, keyrings, and the like have luck, then the permutation becomes linear, which is n factorial. So the important point about circular arrangement is as follows. Number 1, if the clockwise and the counterclockwise orders can be distinguished, then the total number of circular permutation of n elements taken altogether is the quantity of n minus 1 factorial. Number 2, if the clockwise and the counterclockwise orders cannot be distinguished, then the total number of circular permutation of n elements taken altogether is the quantity of n minus 1 factorial divided by 2 without luck, and n factorial with luck. Let's have first an example. In how many ways can 6 people be seated at a round table? P is equal to the quantity of n minus 1 factorial, wherein we have n is equal to 6. So, 6 minus 1 factorial, and 6 minus 1 is equal to 5 factorial. So, P is equal to 120 ways. Number 2, in how many ways can 5 different beads be arranged if a bracelet has no luck for letter A, and B, a bracelet has a luck? So let's solve first for a bracelet with no luck. We have n is equal to 5. So P is equal to 5 minus 1 factorial divided by 2. And 5 minus 1 is equal to 4 factorial divided by 2. And 4 factorial is equal to 24. So we have 24 divided by 2, which is equal to 12 ways. A bracelet has a lock. P is equal to n factorial. So P is equal to 5. N is equal to 5. Wherein 5 factorial is equal to 120. So P is equal to 120 ways. Number 3 example. In how many ways can 3 girls and 3 boys sit around a circular table so that boys and girls alternate? So let us choose to sit the girls around the table first. They can be seated in 3 minus 1 factorial, which is the same as 2 factorial, which is equal to 2 ways. The boys has 6 ways or 3 factorial in sitting between the girls. So we have 2 times 3 factorial or 2 times 6, which is equal to 12 ways of sitting 3 girls and 3 boys around the table alternately. To wrap up, in circular permutation, if the clockwise and the counterclockwise orders can be distinguished, then the total number of circular permutation of n elements taken all together is n minus 1 factorial. And if the clockwise and the counterclockwise orders cannot be distinguished, then the total number of circular permutation of n elements taken all together is n minus 1 factorial divided by 2. And that is for without luck. And n factorial with luck. And for our valuing, I would like you to give your own reflection in this situation. Having an overcrowded schedule is not uncommon for teenagers. Chris, for instance, has to decide among the following activities for Saturday: attend a birthday celebration of a grandparent. Number 2, play basketball with neighbors. 3, watch a movie with classmates. 4, do his homework or project. 5, play computer games. If you were Chris, which activity would you prioritize? Choose your first, second, and third priorities and explain your answer. You may write your insight in your reflection notebook. Now, let's have our post-test. Directions. Identify what is being asked in each question. Write the letter of the correct answer in your paper. Number 1. Which factorial notation is used to permutations of n different things around a keyring and the like? A, B, C, or D? The correct answer is letter B. Number 2. How many different ways can 8 persons be seated in a circular table? A, B, C, or D? The correct answer is letter A. In number 3, in how many ways can 6 couples be seated at a round table if the man and woman want to sit alternately? Is it A, B, C, or D? The correct answer is letter D. For number 4, how many ways can then 10 differently colored beads be threaded on a string? For number 4, how many ways can 10 differently colored beads be threaded on a string? A, B, C, or D? The correct answer is letter B. And for number 5, at a dinner party, 4 men and 4 women sit at a round table. In how many ways can they sit if the women sit together? Is it A, 62, B, 120, C, 144, and D, 576? The correct answer is letter D. I know most of you got a perfect score. Now, I know you are ready to solve the different activities. Good luck, guys! For activity number 1, let's practice. Analyze and solve each problem. Number 1, number 2, number 3, number 4, and number 5. For activity number 2, keep practicing. Solve the following problems. Number 1, number 2, and for activity number 3, test yourself. Direction: solve what is asked in the problem. And here are the key to corrections. I hope you learned something in this topic. Thank you and have a nice day.